Here's a touch of nostalgia for you. This is, believe it or not, a laser. Not the kind that you have today. This is one of the old gas tube lasers. It's a helium neon, pumps out about 1 milliwatt. This was actually a kit made in I got this in 1985, and it's basically this gas laser. You can see that. Had a little shutter to protect people's eyes. Doesn't matter what power your laser is, you don't shine it in people's eyes. The problem is that even though it may be low power, your lens in your eye can focus it, and then the amount of light that's actually hitting a small area of your eye could be magnified to the point where it could cause damage. So even those stupid little cat trainer or those little dollar bin lasers should never be pointed in somebody's eyes. Well, let's take a look inside and see what makes this thing tick. I think you'll be impressed by what it looks like. Back in a sec. That's what's inside. They actually used a tube and had a capillary in the middle, which is basically a glass tube with a very small bore. And they had dichromatic mirrors on either end. Diachromatic? I'm not quite sure what the right pronunciation for that is, but basically it's a stack of reflective quarter wavelength layers built up on just a piece of glass. And with the appropriate number of layers, you increase how much light actually gets reflected. So the whole idea with a laser being a light amplification through stimulated emitted radiation, basically what that means is as the light is generated in the capillary, it goes out one end, hits the mirror, bounces back, stimulates some more photons, gets a little brighter, goes to the other end, bounces back and forth until one of the mirrors is just a slightly less than 100% reflective. And once you reach a certain level of light, the light will actually escape through that mirror. Let's light it up. So there you go. That's what it looks like inside. That's basically helium neon. And you can see the beam. It's hitting the shutter. They usually put a shutter there to protect accidental, pointing it at somebody when they really don't want to. So that tube, I guess it's about 8 inches long. And underneath is basically all the electronics in the old days. That tube needed about 1600 volts to operate. So you don't want to be sticking your fingers in there. So it was designed with a camera mount quarter 20 adapter on the bottom, so you could put it on a tripod. And they actually provided a little audio input, because you could actually modulate the beam on this guy. And if you had a detector far away and you pointed this at it, you could actually communicate one way with it. It was quite the nice little device. It was designed as a trainer. Heathkit made a lot of neat stuff. They're long since gone, but I miss the old days. And the date code on this tube is 1985. And that's, I think, when I bought it and put it together. Just another little item that I thought you might find curious and be interested in knowing the difference between that and a solid state laser. I'll show you the difference in a moment. Right. There's the gas tube, and that little part down there is a solid state laser. That's what we use today to generate a lot more power than even that tube would generate. That tube generates about 1 milliwatt. that particular laser is solid state lasers. Oh, I think not much light here. Good for about 5 to 10 milliwatts. Let me zoom in a bit if I can. All right. It's hard to see, especially with me wiggling around like this. But see that little block in that window? Well, that's not the laser. You see that tiny little chip that's dead center sitting on top of it? Believe it or not, that's the laser. That's a solid state laser device. It's an edge emitting. The light comes out sideways because it's made in layers, and they cleave the ends of the chip to emulate basically the mirrors that are on the tube. Okay, and by doing so, they basically direct most of the light out of one end. Where'd it go? Out of one end of the chip. The back has a little bit of light coming out, but most of it actually comes out the front. By having some light come out the back, they can actually monitor that with a detector so that they can make a circuit that basically is closed loop to make it so they can have constant output power. Sorry for all the jiggly wigglies. I haven't got a GoPro or anything yet, so I'm using my phone. So there you go. Just another little item, one of the many that I'll be posting over time. Curious little devices from the past. What a difference, eh? All right then, have fun, and thanks for watching.